Hey there folks, welcome back, I guess, to business mathematics. This time we'll talk about differentiation. In more specific, we'll talk about higher order derivative. The first higher order derivative that we will learn is the second derivative. This is obtained from deriving a function twice. We can also see this as the first derivative of the first derivative. The notation for the second derivative is f double prime x or d square y over dx square. Let's go straight to the example. So let's say we have Qt is productivity of a morning worker. You can see that Qt is equal to minus t cube plus 6t square plus 24t. We want to find the worker's rate of production at 11 AM and also at what rate is the worker's rate of production changing at 11 AM. We have that the worker's rate of production is the derivative of Q. Let's say it is RT, so R will be equals to Q prime. We can see in the slide. And because 11 AM is 3 hours after 8 AM, we will have the worker's rate of production is 33 units per hour at 11 AM. And if we want to know the rate of change of the rate of production, then we will have to find the second derivative. So we have R prime is equals to Q prime. At 11 AM, we will have that R prime 3 is minus 6 units. This means that the worker's rate of production is decreasing. So it means that the worker is slowing down. In the context of physics, the second derivative can be seen as the acceleration. It is the derivative of velocity v. We can see in this example how it works. And of course, if we have the second derivative, then we can also have the third derivative, the fourth derivative, and so on. Let's say we call them the nth derivative. You can see the notation for them is f n x or d to the power of ny over dx to the power of n. You can see how it works below. And that's it. So thank you for watching this video. But now let's move on to the next topic. And that topic is the chain rule for differentiation. Let's say we have C is the cost that depends on the number of the units produced by a factory. And the number of units produced is Q, which in turn depend on, obviously, times. If we want to find the rate of change of cost with respect to output, then we have dc over dq. If we want to find the rate of change of output with respect to time, we have dq over dt. If we want to find the rate of change of cost with respect to time, then we want to find dc over dt. And this is equals to dc over dq times dq over dt. This is what we call the chain rule. If we want to put it in a more mathematical way, then let's say y is a function of u and u is a function of x. we will have the composite function y is f over gx, and this will be differentiable because fu is differentiable and gx is also differentiable. The derivative dy dx is given by the product of dy du times du dx. Let's go to the example. So we have y is the function like that one. It is a bit complicated, but if we rewrite the function as y equals to u cube minus 3u squared plus 1, where u is x squared plus 2, we will have a simpler function. Thus, dy du is 3u squared minus 6u and du dx is 2x. And we can use the chain rule for that one. So we have dy dx is 3u squared minus 6u times 2x. Don't forget to replace back u with x squared plus 2. So we will have dy dx is something like that. Let's have a more grounded example. We have Cx is the cost of producing x units. Cx is given like that one in dollars, and the production level t hours into a particular production run is xt. We want to know the rate of change of cost with respect to time after 4 hours. Because c depends on x and x depends on t, then we will use the chain rule to find dc dt. We have dc dx is 2/3 of x plus 4, and dx dt is 0.40 plus 0.03. So we multiply them, and when t is 4, we have x4 is 3.32 units, and by substituting t 4 and x 3.32, then we will have dc dt when t is 4 is 10.1277. So after 4 hours, the cost is increasing at the rate of approximately $10.13 per hour. And here's some exercise for you. And so the last one is quite a big one. This is the general power rule. Before we have the power rule of x to the power of n, but this time the power rule applied to power of function. So the derivative of hx to the power of n is n hx to the power of n minus 1 times the derivative of hx.